So the next area we research is exposure of building occupants to different things, but in particular, I'll scale it down to chemicals in the indoor environment, and more specifically, the pathways, how these chemicals enter our body. This is actually a collaboration of a larger group of institutions and persons, since unfortunately this project is still unfunded. This is a group of fantastic volunteers who contribute with their time and facilities and sometimes even private money to move this forward in the past couple of years. So chemicals are all around us. On average, a new study is showing that about 100 unnatural chemical compounds can be found in the blood and urine and body fluids. So basically anyone in the world or in the Western world nowadays which are not supposed to be there. And they come from various sources, from building materials, from clothing, from food or contaminated food, air, of course. And these are, some of them are classified endocrine disrupting chemicals, which can have an adverse effect on our health. They can be toxic, they can mimic hormones. They are measurable in blood, urine, saliva, breast milk, and they are linked to a large range of potential health effects, including neurobehavioral development, reproductive problems. These are some of the major ones being focused upon. Some of the groups of these chemicals are the phthalates, which are plasticizers in mainly plastic products, consumer products, but also personal care products, flame retardants in computers, in cushions, in mattresses, pesticides, and the list is very long. So I want to focus the next couple of minutes on exposure pathways. And you've heard all the saying, you are what you eat, referring that what you eat, that our diet is very important for our both physical and mental health. But let's broaden it a little bit. You are what you ingest, because we don't eat only food, unfortunately. And we breathe air, and our exposure is determined by inhalation. And then there is dermal absorption. And I'm sure you've heard about exposure through skin. And one of the ways to think about it is the nicotine patch. So certainly there are chemicals that penetrate the skin. They are designed to penetrate the skin. But also already in the 1920s, it's been indicated that some of the tobacco harvesters hallucinate every evening, not because they smoke, but because they are constantly in contact with the green tobacco leaves. And that is an indication that certain chemicals can penetrate the skin. Another example is cashiers. They are handling the thermal paper, which is treated with BPA, bisphenol A, and they have a high concentration of BPA in their urine and blood very often. What we wanted to look at, whether our skin actually can work as the skin of a frog. So frogs are breathing through their skin. There is a direct CO2 oxygen exchange through the skin. And of course, our skin doesn't work that way. But maybe there is some potential that our skin works in a similar fashion in terms of exchange of certain chemical compounds. And I'm not going to focus on what's coming out of the skin. That's a whole new different area, very fascinating one that Paulo looked upon. But what goes in through the skin, if anything at all. And this has been shown in the 70s already for some industrial chemicals and solvents, that yes, manufacturers and people working in these plants and factories, they do have some exposure to volatile organic compounds, some light molecules that are in the air where they are produced. But what about these endocrine disrupting chemicals, phthalates, flame retardants, and the chemicals that are in our everyday air that we are exposed to? So we devised an experiment, and you are welcome to worry. These are real people. We exposed 6 people. We asked them to look as if they came from Mars. And we increased the concentration of 2 phthalates in this chamber. DEP is diethyl phthalate, is the one which is mainly in personal care products, shampoos, creams, soaps. DNBP is both in personal care products, but also building materials. And routinely measured both in the air and in dust collected in indoor environments. So these people were exposed 6 hours to this air twice, once wearing a breathing hood, so they were breathing fresh air out from outside that room, and another time without the breathing hood, both breathing this air and being exposed dermally, wearing only shorts. This is actually Pavel, for the record. And We certainly restricted their diet. They didn't eat anything, basically, only tap water they could drink, and collected urine for the next 48 hours after coming out of the chamber. So this is a cumulative excreted amount, so always added up from the previous urination. The total amount of MNBP, that's a metabolite of DNBP, mono and butyl phthalate, and the orange circles stand for the condition with hood, so only dermal exposure, and the blue ones is inhalation and dermal when they were not wearing the hood. And you can see that the difference is about twofold, which means that the difference between dermal and inhalation is inhalation. So inhalation and dermal uptake was more or less the same for this particular subject and chemical. So dermal uptake can be as prevalent or as pronounced as inhalation. We tested a year later the same for nicotine, and I have to say, unfortunately, that it works exactly the same way. Nicotine uptake is substantial and comparable to inhalation for non-smokers in environment where nicotine is present. So we might be now saying, well, but those people were naked, so isn't clothing protecting me? And it's a very good question, and it's a yes and no answer. So if you think about some of the forestry workers, military personnel, people in impregnated or treated uniforms, they have high exposure to certain chemicals of the impregnation, like permethrin. But what about us? So again, an experiment with a set of fresh clothes and a set of clothes which is in that room for a couple of days to equilibrate or absorb up some of the chemicals from the air, and then again a couple of hour exposure through the clothing to that air. To that chemical. And here is the result. So the orange one is from the previous experiment from naked people that you saw, or bare skin, and the black one is about 1/5 wearing clean clothes, and the blue one is a total exposure about 3 times higher wearing exposed clothes. And this poses the question, so what is actually in our clothing in our everyday lives? Does it matter or does it not? Or are we protected or are we not if our clothing is contaminated? So perhaps right now we are all exposed to chemicals that we are having in our homes and not in this air because we brought them in with our clothing from our closets. So it all comes down to the question, what is in our closet? How is the interaction between clothing and air in our homes? And ultimately, a lot of more questions. So basically, in conclusion, yes, we are frogs, not because we are similarly lazy, but we have a skin that interacts in both directions with chemicals. But there are lots of questions still to be answered. The whole dynamics, what happens when you come home, you change your clothes, you put in the old clothes in the wardrobe, or if not, you wash it. Does washing affect? Frequency of washing, duration of storing the clothes, bedding, pajamas, showering, sweating, a lot of questions that we have to keep looking into in the coming years, hopefully. Thank you very much.